If your whole group wants to sit back there, sure, but you need to be with your group. Well, let's wait and see if there's one. I was curious. I thought a couple of the groups were weak last class. Please make sure you have your homework written down in the plan book, which today's box can actually just say same with an arrow up, which some of you probably filled in yesterday. You got to make sure every box is filled in, so you might as well check that right now. I would love it if this class would pay more attention than my previous class and make sure that you have everything that is on the board listed in the please have out. Now, math book is mainly going to be at least one per team. Not every person has to have it, but at least one per team. Francesca. Thank you for asking. Nobody has this yet. If you see something on the board that you don't know what it is, resource page 121, it's normally going to live somewhere right up here. So this at the very top has a header, resource page 121. Please make sure you have one of those as well. Who can bring us back to focus on what we did yesterday? What we were talking about, what our goal was at the fair. Who can bring us back to focus? What was our situation? We kind of got it up on the board, up on the TV. Who was at the fair? Mike, right? Alex, do you remember what Mike's objective was? Yeah. Mike wanted to get the green fish to get the big stuffed animal. Now, the first problem that we were asked, did we go over these yesterday? I don't think we did, right? The answers to these. Do we need to do jumping jacks? Do we need to do jumping jacks? We all look like we're way too tired. I'll give you the choice, that or push-ups, but okay, we need to wake up then.
Jumping jacks.
No. I mean, you can if you want, but yeah, you're crazy. What happened? So, wake up, please. Did we go over the answers to 151 yesterday?
No.
A, B, and C. Okay, I did not think so. So please get your notes back out, your math journal from yesterday. I'm titling this 9-1 because this is my start for today, and our topic is still probability. Please make sure that you're numbering and labeling how I am. I'm catching some journals that, like, you're only making your job harder, because if I can't grade it and find what I'm looking for, it's a check, minus, or a missing. And then you got to take care of it, which is going to take you more time. So 151, A, changed our situation. You want to talk through 151A and tell me what answer you guys got? Oh, by the way, because I did 3 different things yesterday, 3 different classes because it was so goofed up. Did we talk about probability notation yesterday? Where we write P and then a parenthesis? Okay, so I need everybody to get to somewhere new in your notes that you can write. I know you're probably looking at yesterday, but get somewhere that you can write. And you could label this probability notation if you want. What's up, Grant?
Does anyone see a dark blue math journal?
Yeah, I don't know, man. I would just get a sheet of graph paper and figure out how to get it put back in your journal when you find it.
Alright.
Because otherwise you're going to go spend like 10 minutes searching for your journal and you're going to miss a bunch of this.
Right.
Just glue or staple that in or whatever later. What's up? Figure out how to glue or staple or attach that in later. Guys, we can't spend class time on that stuff. I'm sorry, I just don't have enough class time. So probability notation is set up by saying probability of this event. So in A, we're looking for the probability of Mike winning a giant stuffed animal. So what do we want the outcome to be? To win the giant stuffed animal, we need to get green. So probability, we in here would put green, and then equals to build this, to calculate it, to figure it out. It's going to be the number of green over what do you think goes in the denominator? Yeah, the total number of fish. So probability notation is always what you want over everything that you have. What's weird about situation A? Because it changes the tank, right? Situation A says if. What's weird about it? It was only 24 hours ago, guys. Patrick?
It's kind of weird because that game is written in a good way. That means you can always win.
Can always win?
Well, it says all the fish in the tank are green, and to win, you need to pull out a green fish.
Okay, I'm just picking on your phrasing. You can always win?
Will.
You will always win. So what's the probability if you will always win? 100%. Because it says if all the fish in the tank. Well, okay, so there were 10 fish in the tank, and all of them are green. That's 10 over 10, which is 1, which is 100%. By the way, if you haven't noticed, I make my ones kind of weird to make sure that you know it's not an L. Sometimes the part gets a little bit long, but this is like my standard one. Has the base on it, has the little dude on the top. I don't know. I just don't like doing this because that, like, it's can look like low or whatever else. The deeper you get into math, the more letters you use, the more confusing it gets to know what's what. So my handwriting, I just had to start making my ones like that. Some people make their 7s with the little thing across. So whatever you got to do. Now, B goes back to the situation that we have, right? The tank that we have. Can anyone talk through B? The way the tank is set up, 1 green, 3 blue, 6 yellow. What are the chances that Mike will catch a blackfish? So we're going to write this in proper probability notation. We're going to write P and what goes in the parentheses. What is he trying for this time? Black. So P of black. So then my numerator will be how many black, and my denominator will be how many total. So, how many black? How many total? Who can help me? 0. Raise your hand, Marvin. I'm going to call on you to lay your hands on it because you know it. Marvin, how many black are there? How many total fish?
6.
It's how the tank is set up. So 6, 3, and 1. 10. What is 0 divided by 10? What percent would that come out to be?
0.
0%. Because this comes out to be 0 as a number and as well 0%. Now C actually gets down to the actual what we really care about. So how the tank is set up, given the information that we have, what percent of the time do we expect that Mike will catch the green fish? Patrick?
10%.
How do you know?
Because if there's 10 fish, right? If there's 10 fish and 1 green fish, 1 of 10 would be 1/10, and which is also 10%.
So I would like you guys to write probability of green, 1 green over 10 total, because this is going to help you when you go to do your homework. You're looking, how do I set up these probabilities? It's always what you want over the total that you have, which comes out to be 1/10. And to go from a decimal to a percent, we're always working with 100. You know how? You multiply by 100, which shifts your decimal 2 places, and we get 10%. Now 152 goes on to extend this situation. So if you have your book at your desk, or if you want to look up here, 152. By the way, are there any questions on how we got those probabilities in 151? The 100%, the 0%, the 10. I think most of us were pretty good. As I walked around yesterday, I think most of us had that. So 152 kind of summarizes, okay, we figured out the probability is 1/10. By the way, did I show this yesterday that this will pop up with the definition? Any blue words in your digital textbook? So in your real textbook, they'd be bold, but any blue words, if I click on it, it's a hyperlink. It pops up with the definition. So here's what I just showed you, the probability notation. I just made it a bit simpler. So I want you guys as a team to work to answer the questions in 152. So take a few minutes. A breaks down like you want all of the probabilities. And some of you guys started this yesterday, so you might already have a leg up. So talk with your teams, figure out who's done what, and communicate it, make sure everyone understands.
Okay.
It's also on the board if you don't feel like your finger book. As long as you can read it. One of these table groups should have I know. No, I got more. I just thought I had 6 sets. You will need those in just a bit. So let's bring this back together for a second, because I think most of us have processed through A and B. It's got another one of those blue words. So, anybody volunteering to talk me through A on 152? So in my notes, I need to label that this is 152, and then part A. I'm liking purple today. 152, part A. This is relatively how your notes should look, so you know what you're doing and what section, what part, all that stuff. I'm not going to call him Patrick again, because I'm going to have to start paying him if I do. And I don't have the money to do that. So, Alan, what do you think? You guys were trying to determine the probability of blue and then the probability of yellow. Can you give me just the probability of blue as a fraction? 3 out of 10. Now, how'd you know that?
Well,
Why 3? Yeah.
there are 3 bluefish
Out of 10 what? 10 total, right? So the main mistake I see people do here, please don't write this down, just give me your eyes for a second. They will look at a situation, let's say there's 10 fish, 3 of them are blue, and then there's 7 other ones. No. It's blue over total. So I'm trying to tell you this so you don't do it. Since I've seen it, I've been doing this for 5 years, please realize the denominator's got to be the total. So perfect, and that turns into what percent? Either of you guys back there.
It turns into 30 over 100 and then 30.
So if I want to get to percent, that means out of 100, or for every 100, multiply by 10, and I get 30%. I can write it as a fraction, or I can write it with the symbol and then not have to write the denominator. Probability of yellow. Nobody has name temps up today. You're going to make my job really hard. It's really tough for me. Can't figure out who we are. I'm trying to use binders and things like that. I'm sorry, we've been in school like 8 days. I mean, really, class has been awkward a lot. I was about to call you, just so I like your last name. I know you because you're my advisory group. But do you guys have B done? Or you guys have yellow done? No? Yes? Well, Eleanor at least thinks you're done.
Yeah.
All right, Eleanor, help me out. What did you guys have for the fraction for probability of yellow?
6/10.
Which then became what? If I want it now, you may not have this on your paper, but if I want to put this over 100,
60.
it'd be 60, which then becomes 60%. Now B, everyone's going to need to take some notes here. This is really important because it's a new word that you guys don't know. There's a big old word there hidden in B, theoretical probability. Now probability we've been talking about, but theoretical. Excuse me, what does it mean when something is theoretical? Like, we have theoretical physicists, which is actually what Sheldon is on Big Bang, if you watch that. He's a theoretical physicist. What does it mean to be theoretical? Patrick?
Theoretical question is a sort of like what you think it is. I think what
You
yeah.
think it's what you think it is?
I think that it's like an estimate. It's what you think the answer's gonna be. It's like an estimate.
Pretty good. Pretty close. I mean, I would just pepper a couple words in there that were a bit more mathy. So, theoretical probability is our prediction of outcomes based off known, that's a bad K. Can't let that stay there. Sometimes I get like, I lift off the smartboard and then I gotta start over. Now, contrary to theoretical, again, not trying to play gotcha, but I know some of us did our homework and some of us probably didn't. There was another type of probability that was involved in your homework that was not theoretical. Alex? Experimental. Now, do you know what experimental probability is or how it's different than the theoretical?
It's when you try stuff.
Yeah. So, on the contrary, experimental probability, you guys are more than welcome to abbreviate probability. It's a long word to write. Experimental probability is we do it, we test it, we run the experiment, and then we use that data. So we do it, and then calculate probability based off that. Use results to express the probability, I guess we can say. So theoretical versus experimental is the difference, like Patrick said, between thinking about it and what Alex said of doing it. So theoretical is easier. I just have to think and calculate. Although some people will argue the other side, experimental is easier, all I have to do is do it. Somebody last year, maybe it was a couple years ago, argued when I was talking about a coin flip that the probability was not 1/2. And I said, okay, why? Well, there's an edge that it could land on. It could potentially stand up like this. Which, yeah, I argue, no, it can't. So we were arguing back and forth. Theoretically, it has two outcomes, heads and tails. Well, he argued, no, it has more than that. So I said, all right, run the experiment. Do it 1,000 times. Keep track of your results. Well, he did not run it 1,000 times. But after about 10 or 20 or 30, you can figure out this isn't happening, right? That third result of it standing up on end just doesn't happen. So if you make a prediction and people are like, oh, that's totally off, like you just run the experiment and test it. And a lot of times this happens like long term. I don't know about the Large Hadron Collider, or I might be saying it wrong. People emphasize it a little differently. It's running experiments of what happens when we slam particles against each other. Yeah, lots of people have lots of ideas, but we can't really figure it out until we do it. So yeah, sometimes you just gotta go and test it. Difference between theory and experimental. Think about it, do it. Cool? So, what probabilities have we been discussing then? Have we been discussing experimentals or theoreticals? Theoreticals. We've not done the game. We've not gone and caught our fish. Could I go there, play the game 10 times, and catch 0 green fish? Yeah. Could I go there, play the game 10 times, and catch all green fish? Yeah. My experimental probability will not always, and actually it's quite often, different than the theoretical. Now, this brings in a very, very cool, now I hate calling it a law, but you don't have to write this down. There's this law called the law of large numbers, and what that says is that if you have a theoretical probability that's been calculated correctly, we calculate our probabilities, and you run an experiment to infinity. Well, you can't really run it to infinity, but the longer you do it, the closer your actual outcomes will get to the prediction. So, coin flip, right? Half and half. 50%, 50%. If I flip a coin 5 times, I definitely won't get that. Why? And what's wrong with that then? Why can't I get 50% out of 5 flips? Because it's odd. You can't have half of 5. Could I get 50% of 10 flips? So the longer, now 100 flips, 1,000 flips, as I flip the coin more times, and you can try this, you got a 3-day weekend, you will get closer and closer to 50% on each outcome. People have tried it before. And there's simulators and things like that. So, our theoretical probability, we talked about green, yellow, and blue. And we've got that. So we will at some point run experimental probabilities. But we now have been asked to build a fish tank. Now, they've given us theoretical probabilities that they want us to try to make true. So I'm going to help you with A, and then I'm going to release you guys on your own for your team. So label in your notes, we're moving on to 153A. They tell you that you need to build a game that has a probability of green winning. So I'm going to go ahead and write probability of green needs to be 2/7. Does that mean that I'm only ever allowed to have 7 fish in the tank? What else could I do, Aubrey? Do you know another amount of fish that I could have in the tank? 10 won't work here, actually. Grant?
14.
Why?
Because if you just double them both, you can technically still get the same outcome.
So, could I, in my tank, don't write right now, just give me your brain. Could I put in 2 green and 5 blue and have 2/7 probability? 2 green, 5 blue, I have 7 fish total. Great. But Grant's saying, I don't want just 7 fish. That's a lame game. People are going to walk by and be like, eh. I could double the green fish, double the total fish. Will 4/14 be the same as 2/7? So I could do the same thing tripling and do 6 over, what would be my total then? 21. So your answers will not all be the same because you can manipulate the fraction. So now I'm going to say 6 green because I'm going to stop right here. I need 15 more fish. So I'll say 5 blue and 10 yellow, and I'm done. So please write down something for what you would do for A. You could use the 2/7. You could use the 4/14. You could use the 6/21. Or make another manipulation on your own. Then solve out and discuss problems B, C, and D as your team. Give you a few minutes to do that. Turn the volume up like 3 clicks, guys. Very quiet. Thank you, I appreciate it. Hey guys, no gym option today in the middle of the day. There's a long story that I apparently need filled in on later. But so you're either going lunch or AO. There's no gym option. So if you're not at lunch, you're here in AO. You're AO or reading or whatever you're doing down here. So sorry, we have other programs in the building. You don't control everything. So something to do with one of the other programs, but we just aren't using the gym today. You will survive, I promise. You have a 3-day weekend. So do I. I'm gonna go. I'm hopefully gonna be floating on the river by 5 o'clock. Nice. High five, water. You're gonna be in the water for 2 days straight. You're gonna get pruned. It is gonna be cold all weekend. Well, actually, Sunday and Monday are gonna be really good. Okay, there you go. You're still gonna get pruned though. All right, you can keep working, but I'm going to ask for volunteers who can help me out. If they want the probability of winning green to be 5 out of 7, how did you stock your fish tank?
200, 1400.
So, hold on. You said 200. I love it, but that's a really big fish tank. So what did you multiply by?
Wait, no, that's what A.
For oh, I'm asking for B. So that probably would work for A. What? So wait. If you did 200, it has to be 200, 700 if you're doing A. Because if you multiply by 100 on top, you'd have to multiply by 100 on bottom. Hey guys, we got people sharing. You can keep working, but if you're talking in your group, try to keep it quiet because I'm trying to hear. 1,000 and what? 1,400. So what did you multiply by on top and bottom? How do I go from 5 times 200? So what our team over here did was they decided to have the biggest fish tank at the fair. That's how you attract people, right? It's like, we have 1,400 fish here. Fish. Right, rubber duckies, whatever. But, so your breakdown then would have been, how many green? How many green? If this is what they manipulated their fraction to, how many green would you have to have? 1,000. It's got to be your numerator value. 1,000 green. What else do you got? This was your guys' problem. You have 400 fish left over. Hey, we're still on B. We got to talk about the other fish. So make sure you guys are reading the directions of these problems. I have a feeling some of us are like skimming and it's not working well. It asks us, you need to identify how many of each color fish you will have. So I'm going to get creative here. You have 1,000 green. I'm going to do 100 orange. We haven't used those yet. 100 yellow. 100 blue, and then 100 rainbow, because the rainbow fish is the nicest fish in all the ocean. The rainbow fish that'll give you its colored scales. Rainbow fish, you know that story. It's a wonderful story.
Wait, if it's a rainbow fish, then it is.
Each one of his scales is a different color. Yeah, the rainbow fish, each one of his scales is a different color.
So technically speaking, could be considered a rainbow fish?
No, because it's not just green, it's rainbow. Oh, I'll try to find a copy of it. Have you read Hunger Caterpillar? Okay. Alright. Who can talk to me about C? Shh, bring it back. Who can talk to me about C? Aubrey, you want to talk to me about C? How'd you stock your fish tank? Okay, what'd you turn it into? 1614, okay. So explain to me what that means. How many fish? $14 what? How many? What color? Give me your eyes and ears. I need to see eyeballs. Here's what Aubrey just told me to do. She said multiply, double, right? Sweet. Double the top, double the bottom. I now have 16 green fish and 14 total fish. That was like mic drop. I now have 16 green fish out of a total 14. I have 16 green and 14 total.
You have 2 tanks.
No, I mean, okay, so I split them. I have 16 green fish and only 14 total.
You have 14 in one, and then the other 2.
You can't fish both tanks at the same time. Yeah. Thank you. Delaney.
There's 16 fish in total, and
No, there's not. There's 14 fish in total. But 16 of them are green. Liam?
can you triple the bottom number and double the top?
No, then you'd be like changing your fraction.
Same exact thing. Yeah.
Grant? How could you have 16 green when you only have 14 total? This doesn't work. Probability, as we talked about yesterday. Probability, and you might want to jot this in your notes. Probability has to range between 0, which is 0% will not happen. We had that bar yesterday, the line that we filled in, up to 1. 1 is your 100%. 1 is absolutely certain. This is bigger than that. Doesn't make any sense. It's broken. You can't do it. Unless you somehow have like some negative fish. You got 16 green and then 2 negatives. He's going to pop out and be like, you're not going to catch anything today. That would be a negative fish. Get it? So, bad jokes aside, D. 7 sevens. Who can explain your fish tank here? Who can explain your fish tank here? I haven't really heard from anyone but Marvin back there. Somebody from Marvin's group, not Marvin, talk to me about D. Did you guys get that far?
Nope.
Did you guys get that far? Patrick, I've talked to you a lot today. Liam, what about D?
Say you have like 7 blue fish and 7 fish in total. And
Wait, 7 what fish and 7?
Like blue fish, I guess, or green fish.
Ah, so be real careful. This probability is probability of green. Now, if I look at 7 sevenths as probability, what's that turn into? 100%. So you said I could have 7 orange, sorry, I'm writing in orange. 7 green and 7 total. So all that means is all my fish are green.
Yeah.
So what if I had 9 green fish? Will that work? As long as I have 9 total. What if I have 12 green fish? As long as so really, what this turns into is any number of green, as long as, that's a Z, by the way, not a 2, as long as that's the same as the total. It could be 2,472, as long as it's 2,472. As long as they're the same. Yeah. Wait, never mind. All right, your next challenge is you decided you don't like the fish. They start to smell, the water's everywhere, too hard, and somebody broke your aquarium. So you're changing your booth. Right, you are now going to create a spinner game. So you've been given this. The spinner in front of you, your resource page. If you don't have it, please get it. You've been given this spinner. Now, your goal, hey guys, I don't want to keep us in the lunch. I'd love to let you out early. Your goal is to make this happen. Your spinner probabilities need to be 40% red, 30% blue, a 10th yellow, and the rest of them are green. That's your goal right now as your team. Now, your spinners do not have to look identical, but the probabilities better be the same. No, you each should have one of the pages. And that's why you have the colored pencils.
Alright, so when should actually be over here. Alright, everyone no, what is that? I don't know what I need rules.
Yo. What? The colors are in your book. Yeah, the instructions are in your book. Yeah. When I show the stuff on the screen, that's just the digital textbook. So yeah, right here, 40% red, 1/10 yellow, all that I've been around for a while. Hey, I'll go subscribe to you if you want. All right, you can keep working, but what's the first thing you did? Who can tell me the first step you took? Alex, what'd you do? Counted up and got 20. So we know there's 20 total. 20 total wedges. So then the first thing everybody approached was 40% red. How do we make that happen? How do we determine how many wedges? Patrick?
So what I'm thinking is that we gotta figure out what 40% of 20 is.
Ooh, now what does of tell me to do mathematically? You just said 40% of 20.
Isn't it divide?
Grant? No, that's per.
Oh no.
Of is multiplied. You have two sets of 3, 2 times 3. So 40% of the 20. What's 40% written as a number I could actually like calculate and use? Because I can't use this unless I can plug in a percent symbol, and we don't like to. So this 40% is really 40 over 100, which is really just 0.4. So when I go to do the math, we can do 0.4 times the 20. What's 4 times 2? There you go. Because I moved this decimal. Now we'll talk about this another day. But I can bump both decimals in, and it compensates each other. 8 should be red. Keep working.
And 6 are blue.
Hey, don't go crazy with the colored pencils. These have to last us all year, so just do some light shading, like some squigglies so you just know that it's red. So, like, here's how I would color, because I'm lazy.
Very, very silent. You remind me of Miss Rose.
Of who?
Miss Rose.
I learned from Bob Ross. You ever came with Bob Ross?
I made a show.
He's a televised art, like, instructional. When we look at our blues, a lot of us have moved on forward. When we look at blues, 30% should be blue. So when we go to calculate that, Grant, you got 0.3 times 20, which gives us 6 wedges or 6 blue spaces. How can I find a tenth of something? Division by what? 20 divided by 10. So, yellow, and this is a hard color to do up here. I'm going to have to try like a mustard here. You still can't really see that, but... My question for you really is, what's the percent chance green will win here? What do you think? You think green is 40%? How do you think that? So, our probability of green is always going to be green over total. Right? Green over total. How many green wedges? Anybody?
4.
4. How many total wedges? 20. If we go to calculate the probability of green, guys, because this is where this gets dangerous. This is where people make their mistakes. Amount of green over amount of total. Do the math. Or simplify it down. Or what's percent mean? Percent is out of 100. Can I make this denominator a 100? What do I multiply by to get there? 5. 20. So green has a 20% chance. Now your homework tonight is the same as it was yesterday, so your plan book should say same. Your team cannot leave until every colored pencil gets back in that box. That box, one person resource manager really, bring back up to here, please. My little bin of supplies. Then you guys are good to go. Have a wonderful weekend. Enjoy your extra day.